Hello, my lovely viewers. Welcome again to Mathematics and I. It is your presenter, Jefferson. And today we are still on the topic variation. And remember in our last video, we treated direct variation. And we said direct variation shows the relationship between two quantities, such as one of the quantity increase, the other also increase, and vice versa. So today, we shall be looking at the other type of variation, which is called the inverse variation. Inverse or indirect variation. Now, the inverse or indirect variation. Now, when you say inverse variation, what do you understand by inverse variation? Inverse variation simply shows the relationship between two quantities, such as one of the quantity increases, the other decreases. And as the order increases, the order also decreases. That is how inverse variation, you see, it is not like direct variation. So, if for instance, you as a consumer, you go to the market to buy a pair of shoes, and then we say, if this is naira, and this is quantity demanded, and if we say for 30 naira, you are able to purchase two quantity or two pairs of shoes. And then, when the price increased from 30 naira to 40 naira, then your purchasing power reduced from 2 to 1. What has happened? This is an inverse relationship, because as the price increases, the quantity demanded reduces. An inverse relationship. And that is the reason why you see that the slope of a demand curve is negatively slow, because why? As the price increases, the quantity demanded decreases. So now that we understand what inverse relationship or inverse variation means, how do you solve problems with inverse variation? Now remember, we said in our last video that there must be two things you must put in mind when you are solving variation. The first is to look for the constant of proportionality, which is the K, and then the second is to look for the relationship. And now how can we apply this solving inverse variation? Let us go. Also, we are looking at just two examples, and after these two examples, we are done with inverse variation. Now, example number one. Now, example number one says, if x varies inversely as y, comma, when x equal to 10, comma, y equal to 4, full stop. Find, comma, Roman figure 1, the value of x when y is 2. Now, let us take a look at this question. You will notice that it is different from yesterday. Yesterday, or in our last video, it was a direct variation question. Now, this is an inverse variation question. How do we go about it? Solution. Now, bringing back the question again, x varies inversely as y. When you say inversely, it becomes 1 over the quantity or 1 over the variable that is varying it. But if it was direct variation, the y would be here. X varies directly as y. That's all. Now that we have bring out the question, what do? We introduce our constant of proportionality, which is k. So here becomes x is equal to k over y. Now, like I said, you will notice that the value of x and the value of y was given initially. Why? It is for us to get the value of our constant. So what does that mean? What was x? X was 10 and our y was 4. Now, it means anywhere I see x, I give the value of 10. And anywhere I see y, I give the value of 4. So automatically here becomes 10 is equal to k over 4. What do? Base here over 1 and cross multiply. K times 1 gives us k. 4 times 10 gives us 40. Meaning the value of our constant is 40. We have gotten step 1. Now step 2 has to do with us looking for the relationship connecting x and y. Now let's go there. Relationship is. Now remember we said, how do you get your relationship? The very place you introduce your constant, which is here. So it means when I'm writing this, it becomes x is equal to, wherever I see my constant, what do I give? 40 over y. This becomes the relationship connecting x and y. Now, we were not told to look for the constants. We were not told to look for the relationship, but we must look for this. So that we can be able to solve Roman figure 1, which says we should find the value of x when y is 2. Now, without wasting time, Roman figure 1. Now, they said we should find x, meaning x is unknown. We don't know x. But they said when y is 2, comma, y is 2. Now, what do we do to solve this? Now, we use the relationship to solve this math. It means anywhere I see x, I still give x because I don't know the value of x. Now, here becomes 40 over. Anywhere I see y, what do I give now? 2. Now, class, 40 divided by 2 will give us 20. It means x is equal to 20. Example number 1. Now, this is as simple as ABCD. Now, let us go to example number 2 without wasting time. Now, example number 2 says, if n varies inversely as the sum of n and q, comma, when m equal to 4, n equal to 1, and q equal to 2, full stop. Find Roman figure 1. The relationship connecting m, n, and q. Roman figure 2. Find the value of m when n is 4 and q is 3. Okay, now let us take a look at this question and solve. Now, if m varies inversely as the sum of n and q, when m is 4, n is 1, and q is 2, find this, and this. Now, remember, before we can get the relationship, we must look for the value of the constant. Don't forget that. Now, solving this math, we have this m varies inversely as the sum. The sum of n and q simply means n plus q. That means sum. Sum is addition. Now, when we introduce our constant, it becomes m is equal to k over n plus q. Now, what do? We look for the value of the constant. And for us to get the value of the constant, the values of m, n, and q must be given. And yes, it was given. M was 4, n was 1, and q was 2. Now, what does that mean? Anywhere I see m, I give 4 is equal to k over n is 1 plus q is 2. Now, without wasting time, 1 plus 2 will give us 3. So what do we have? 4 is equal to k over 3. Now, base 4 over 1 and cross multiply. K times 1 gives us k, 4 times 3 gives us 12. Automatically, this becomes the value of the constant. Now, what did Roman figure 1 said we should do? Roman figure 1 said, find the relationship. Relationship is, how did I say you get a relationship? The very point you introduce your constant. Here becomes m is equal to, now k now is 12. 12 over n plus q. That becomes the relationship. Roman figure 1. Now, Roman figure 2 says, we should find the value of n. Roman figure 2. We should find m. What does that mean? It means m is unknown because we don't know m, comma, N is 4 and Q is 3. Now, what are we using to solve Roman figure 2 now? Our relationship. Now, using our relationship, anywhere I see M, I will still give M because I don't know the value of M. So here becomes M is equal to 12 over N now is 4 plus Q is 3. Now, without wasting time, what do we have? M is equal to 12 over 7. Now, 12 over 7 is an improper fraction because why? The numerator is bigger than the denominator. So let us convert to a mixed fraction. Therefore, M becomes, how many times will 7 go into 12? 1 times. Remember what? 5. All over 7. Simple as this. So class, we have been able to see how inverse variation works. Firstly, what is inverse variation? It shows the relationship between two quantities, such as one of the quantity increases, the other decreases, and vice versa. And I believe you still understood that when we are solving with inverse variation, we must follow the 2 steps that was given from the beginning of the class, which is finding the constant of proportionality and then finding the relationship. From there, you can continue solving whichever question is given to you. I believe that you have learned something new today under inverse variation. Till we meet again in our next class, don't forget to subscribe to our YouTube channel. Don't forget to like our Facebook page. Don't forget to share and comment. Till we meet again, God bless you.